Welcome back. So, in this particular lesson, we are going to learn about token consumption, which is an extremely important topic when we are dealing with AI. So, in the previous lessons, we have already covered what exactly is a token. But just to give a full recap, a token, if you take a sentence and if you break it down into small pieces, each piece is called as a token. A token can be one entire word or part of word as well. So unbelievable will uh, unbelievable actually consists of three different tokens: unbelieve and able. These are three different tokens. Each punctuation counts as a different token. Each space also counts as a different token, and all these special characters, emojis, they all count as different tokens. So these so if you take chat gpt is great as an example. Chat g and then pt is great, full stop. All of these are different tokens, and in the previous lesson I've explained very clearly how we can get these tokens, how powerful these are, how are they actually created, and we have covered a lot of different things about tokens. But we need to understand the mechanism of token counting. So token counting is essentially very simple. So let's go to whiteboard again. Friendly escalator. I'll take the same sentence. What is AI? Let's assume that this is my input, my question, and this is my output. So I asked, what is AI? And the LLM gave me the response, artificial intelligence is transforming industries. So this is the output that I've got. Now, for each token, for each, how to say, each token, it is going to be converted into an embedding. So the LLM responses are going to be embeddings. So it will give you an embedding as an output. That embedding will be converted into token. From token, we will get the word which represents that token, and then we will show it in the user interface to the user. So if I have to draw it, LLM will give me embedding, which will look like this. So this is like simple embedding. This embedding will be converted into a token. Token ID 191. Or let's go 20718. That is the token ID. So this particular embedding, if you convert that into token, you'll get the token ID of 20718. And they will have a huge mapping table. It's not going to be an actual table, but it's easy to understand if I use table format. You will have token ID, the word for it, and the embedding. So what happens is, once the LLM gives out an embedding, we will get the actual token ID 20718. So for this particular embedding ID, I know that this is my token ID, so I'll get that. And along with that, this is my word. Or actually, let's go with this. This is my word, right? So I'm going to get this as the final output. So the LLM job is to give me the embedding, nothing more than that. Then it's just very basic Python if else conditions, if else code, where I'm getting the token ID. And for that token ID, whatever I have the word, I'm getting that word, and I'll be showing that to the user finally. As simple as that. So this is the overall process. But here, if you see, the input is what is AI, and the output is artificial intelligence is transforming industries, which means each token is an embedding. So let's say if I'm sending this piece, then you can understand that the embeddings for each token, if I combine all of them, it's going to be really huge. So that whole array has to be sent, which means now the LLM is not dealing with just one token, but one, two, three, four different tokens. And let's take any one of these examples. If you see here, there are n number of tokens in this. So which means each word has a huge size of embeddings. So combined all of this, you can imagine how big the array is going to be for all the combined embeddings. So this will rise a problem because LLMs can handle only up to certain length. Let's say this whole length is for uh, 50,000 tokens only. It cannot go beyond 50,000 no matter what. So let's say if I have a conversation, this green is my, blue is my input, green is my output. Okay, so these can be like this, can be like this, or like this, or like this. It can be anything. It can be even this as well. But they will always have to fit within these 50,000 tokens only. It cannot go beyond that because the actual LLM model input size is restricted. It cannot take whatever length you give it. So which means, as I told you before, LLMs are basically going to predict the next word. So under the hood, what is going to happen is this is your input, this is your output, right? So for giving this last word, what it will do is it will construct a string. What is AI slash n? This is going to be the input. This word should be the output, right? Which means this input has to be less than 50,000 tokens. Only if it is less than 50,000 tokens, it will be able to create this one. But if the input itself is 50,000 or more than 50, it will not accept if it is more than 50,000. First of all, you'll get a error message. But if it is exactly 50,000, it cannot give out anything extra. So because of that reason, what we usually do is, sorry, what the backend actually does is, if you see this, the whole thing has to be under 50,000, which means the input and the output combined should be less than 50,000. This was my input and this was my output so far. Not the complete output, but so far this is what it has been writing. Yeah, there you go. So which means your input plus output should be within the token length. So it should be within 50,000. This 50,000 number is what you call as token context length. Okay, so it has to be less than the token context length. And in this case, the token context length is 50,000 tokens. So within this 50,000, I can have one output extremely long or one input extremely long or all input outputs very, very short. I can divide it anyhow I want, but they all have to be within 50,000 only. If you give something beyond 50,000, the model is not going to accept it. It will throw you an error message simply. So this is a very important thing that we need to understand when we are doing a token counting. Uh, Next, one more thing we need to understand is for all the API that we are going to use, that we are already using, if I go all the way to the very beginning, yeah. So here we are sending a request and we are getting the output, right? But we have to pay something. So for each request, it has to incur some cost, right? $100 or $1 or $0.1, something like that. It has to incur some cost. The way this cost is calculated depends upon your token context length. Where were we? Sorry about that. Yeah. So the cost depends upon the input context length. So which means if you are sending very, very huge, very lengthy messages, or if you're asking it to generate something which is going to be very lengthy, your input plus output together, it's going to consume more number of tokens. And as a result of that, you'll be paying more amount. So let's say if your input is small, output is also very small, then you won't have any of these. So input is small, output is small, overall token consumption, forget about 50,000. This is only like what, 100 tokens. So you'll be paying only for 100 tokens, not more than that. For 100 tokens, it's very, very less. But for 50,000 tokens, obviously the cost is going to be slightly higher. So the cost depends heavily upon your input tokens plus output tokens combined. So you need to make sure that if you want to minimize the cost, we need to make sure that either the input is small or the output is small. If you are expecting for a bigger input, bigger output, then you have to pay the amount as well. So that is about token counting. And significance of token context length, I've already explained. GPT-4o is using 128,000 tokens, not 50,000, but 128,000. Claude 3 is using 200,000 tokens. And with developer preview, you can get up to 1 million tokens. And Gemini 1.5 Pro is already using 1 million tokens. So these numbers are uh, according to the current date, but these may change in the future also. So you can easily understand how powerful all these different models are. Next, adjusting the context in Azure AI Studio. So if you remember in the very first video, I've told you guys that we'll come back to this particular screen once again in the future. This is that point. So here in the AI Foundry, I've opened the deployment. If I go into edit, yeah, this is the same window. You can see token per minute rate limit. This is the actual token context length per minute. So if I change it to 200,000, So this is the maximum that I can go for this GPT 4.1 mini model, which is allowed in my quota again. You can read more about it from this particular link, but this is where you can set the token context length. So let's say if you are building a chatbot where you don't want the uh, users to give huge input and expect huge outputs because you want to keep the cost as less as possible, then you can go for a slightly lower token context length, like maybe 30,000 or something. Or if you want to build an extremely powerful chatbot where you're letting the users give whatever input they want, and the AI can write as huge outputs as it wants, then you can set it to a higher limit. So this part is something that you have to configure as per your requirement. But usually we just leave it at default. And the token, can I see the cost here? Uh, I don't think so. I'll have to look at the documentation to get the actual cost for this particular model. But essentially, it's also going to be the same. It will calculate the input token plus output token, then it will give me the cost. Keep in mind, this cost calculation is done per request. So let's say if I'm sending my previous 10 conversations, previous 10 question answers plus the current question, all of that counts as one input, and whatever answer it is going to generate counts as one output. I'll combine both of them. I'll calculate the cost. I'll get it somewhere about $1, let's say. In the next question, I'm sending all the previous questions again along with my new question, or I'll draw it actually. Iteration one, iteration two. There are two iterations. So in the first iteration, I'll take these same things. I've got my input one, output one, input two. I got this as the output for the second one. This is my third input, and this is what I'm going to get from the LLM model. Okay, so I'm passing these as my input. My output is this, and for this whole conversation, for this whole iteration, I got my bill as uh, $1, which is very high actually. We don't usually get $1. But in the next iteration, I'll ask a follow-up question where all of this is my input, and I've got my fourth input now, for which it will write fourth output. This time I will get $1.1 again. Just because it previously processed one and two input outputs doesn't mean that it is going to ignore it again. So for every single iteration, whatever you are passing as input will definitely count for calculating the cost. This includes your system instructions as well. So in the Python code, we have previously observed that we can pass these system instructions properly, right? So if you're writing a very huge, lengthy system instructions, as I told you during the structured output lesson, uh, assume that you want to get your output in a certain format. If you're begging it to give it only in that format, you'll have to write down such a huge prompt, And every time you're calling that LLM with that system instruction, you're incurring more and more and more cost. But if you're using that structured response format thing that I've explained before, then you are not going to pay for the tokens that much. So this is one of the way of saying your token cost. But essentially, for every time you call your API, you will whatever inputs that you're passing, the cost will be calculated according to the inputs plus the output. It will not ignore anything. Okay, every call is treated as an individual call. And coming back, yeah, that is how we can set the context length in Azure AI Studio.